Hello, this is lesson 6.5, Operations with Radical Expressions. Now our objectives in this section is we're going to learn to simplify and what it means to simplify a radical, and we're going to do all four operations. We're going to add, subtract, multiply, and divide and learn the rules for that. All right, so let's dig right into example 1. But before we do that, if you notice I've got your vocabulary and then I put all the key concept boxes together before the example started. That way you have them all together and you can make notes a lot easier and easier to go back and review your notes. So the first one we're going to look at, key concept box, is the product rule of radicals. So basically, in a nutshell, I'm not going to read this because you can read, is tell you what does it mean. So the property, what the property says, if you have the same index, so remember, what does it mean to have the same index? So okay, so I have here nothing written. This is where the index goes, and because there's nothing here, it's an implied 2. Do I have the same index? So the rule says when you're multiplying radicals, as long as you have the same index, you can put them under the same radical or you can separate them. For instance, square root of 2 times square root of 8, because they both have them, you can put them under one radical and multiply, which gives you square root of 16, which we know is a perfect square, which equals 4. Likewise, you can break it down if you need to and go the other way. Okay, so let's look at the example. The example says simplify the square root of 32x to the 8th. So let's go look at that one. Square root of 32x to the 8th. Well, it might be easier if you simplify square root of 32 times the square root of x to the 8th. Remember, you can break it to separate radicals with the same index, which is an implied 2, right? And we know that this, if you know this is 2 to the 5th power. So if you wanted to, you could, there's different ways of looking at it. It's 2 to the 4th times the square root of 2 times the square root of x to the 8th. Well, remember we do 8 divided by 2. So remember, this is even, and I have a variable. This becomes what? 4 remainder 0, sorry, I can't multiply. So which means you've got an x to the 4th power with x to the 0 left under the radical, which is just 1, which is just nothing, because 1 times x to the 4th is x to the 4th. So this one is done. Now, our result, my power is even, so I don't have to worry about absolute value signs. Here, 4 divided by 2 is 2 remainder 0. So you have 2 square that you take out, which is 4, and nothing left. And here you only have 1, so it's a square root of 2. You put it all together, you get 4x to the 4th square root of 2. All right, let's try B. B tells us we have the 4th root of 16, a to the 24th, and b to the 13th. We can break it down if we wanted to separate ones. Or what is the 4th root of 16? Well, 16, you got to know, breaks down to 4 times 4, right? Doesn't have to be prime. I need 4 of them. So this breaks down to 2, 2, 2, 2. So 2 to the 4th. So that means I can take 1, 2 out, right? Because 16 is equal to this, and I need 4. Now we do 24 divided by 4 gives me 6 remainder 0. And I do 13 divided by 4, and I get 3 remainder 1. So this is for the A, and this is for the B. So I take out an a to the 6th power, and I have no a's left over. Then here I take out b to the 3rd power, and I have one b to the 1st left in there because I don't have enough to take out another group of 4. And then, so let's go back and look at this is even. I have variables, so I have to look at their powers of the result. Is this odd or even? It's even, so there's no problem. This is odd. which means we put an absolute value around it. And that's your answer. So pause this, do the guided practice 1A and 1B, and then we'll see you back at example 2. All right, so example 2 says, we're simplifying expressions with the quotient property. So now we're going to look at, we have vocab and we have the key concept. So let's look at those. So our vocab is going to be rationalizing the denominator, which says when you multiply the numerator and the denominator by a quantity so that the radicand has an exact root. So basically it'll make sense when we actually do the division, rationalize. We've rationalized before with imaginary numbers. So let's look at how we are going to rationalize this. So let's look at the key concept for quotient. So basically it says, just like the product rule, for any real numbers a and b cannot equal 0 because that's in the denominator, make it undefined, and n is greater than 1, then they're all defined. You can separate. As long as you have the same index, you can put them together. Or you can separate them into two separate ones. So for instance here, this was separated, but we know 3 is a factor of 27, so we can put it, they have the same index, just like multiplication. We put them in the same radical and we get 27 divided by 3, which gives us the square root of 9, or 3. Okay? Now, we'll come back to this when we're doing the problem and rationalizing. So we'll come back to this little box here. So let's look at the examples that they give us. So they give us, for example, 2a. They say simplify, and they have one radical sign, and they have x to the 6th over y to the 7th. Well, y is not a factor of x. So for me, if the denominator is not complete denominator is not a factor of the numerator, I'm going to separate them and simplify them separately. Okay, they have to keep the same index. So remember, it's 6 divided by 2 gives me 3, remainder 0. So the index is even for both of these, and I have variables, so I have to look at the result. So my result is going to be x to the 3rd with nothing left. Here I get 7 divided by 2 is 3, remainder 1. So I get y to the 3rd radical y to the 1st. Now, to simplify this, we cannot have a radical in denominator. So we're going to rationalize, and this is where we go back to that key concept box. It says, this is pertaining to the denominator. If it's the square root of b, then you just multiply it by the square root of b, and the radicals will cancel out. But remember, it's a fraction. What you do to the numerator, you must do to the denominator. It's really important that you realize it's still a fraction rule. Now, if you have anything other than 2, then to rationalize it, the easiest way to do this is to take the index minus the power of the exponent. And for instance here, this is cube root of 3. So it's not 2, so it falls in this case. So we take the index as 3. 2 is raised to the 1st power, so 3 minus 1 is 2. So we're going to multiply this denominator by the cube root of 2 squared. So we're talking about the radicand is what we're doing. So we have to do the same thing to the numerator, and then we can rationalize, because then we get 3 2's, right? Cube root of 2 times the cube root of 4 is the cube root of 8, which is 2. And we get rid of the radical. We've rationalized. So let's look at the example and process this. Okay, so we have to multiply. So here we have the square root. So we're going to multiply. We don't care about this. We can leave this here. So don't try and multiply by this. So simplify first, because then you have to go back and reduce. And we know a lot of you forget to do that. So again, some form of 1. So I have x cubed square root of y all over y cubed, and the square root of y times square root of y, and I'm going to come over here and just show you. So square root of y times square root of y is going to be square root of y times y, or y squared, which simply is what? Y to the 1st. right? So times y to the first. So we get x cubed square root of y over y to the fourth. And now remember, this isn't a radical. This is not. They cannot reduce or simplify or cancel out. Now, I had an even index. Variables. You look at what's taken out. You don't care what's left in. So what's taken out is y to the fourth. It's an even power. We're good with this is odd. So guess what we have to do? We must put absolute value signs around the x cubed. Let's do example 2b. So example 2b is the fourth root of 6 over 5x. Well, 5x is not a factor of 6, so I'm going to separate them. And I notice that 6 is 2 times 3, so I can't simplify, and I can't simplify this. This is simplified. However, I have a radical. But my index is not 2, so I need to multiply. So put your box so you don't forget, because you know you have to multiply by some form of 1. So then if I look at it, so my index is 4, so 4, and these are minus 1 is 3, so I've got, don't forget your radical, and your index is the same, 5 to the third power. They just coincidentally have the same power, but they don't, so that's why you have to do them individually. 4 minus 1 is x cubed, but they coincidentally have the same power, so you're multiplying by the same power. So don't assume that you just multiply by the same power. So then we have to do the same thing up here. Okay, so then when we rationalize, we get 4. We put these into the same thing, so we can take in the denominator, we can take out a 5 and an x to the first, and then we're left with, this is 3 5s, not enough to take out prime, this is 2 and 3, so 6 times 125 gives you, so we still have, don't forget this because I will count off if you don't put your index right, 750, and then we have 3 x's, not enough to take one out, but this is to the first power, we had even. The book forgets to put this in here. They made a mistake. So this is the actual answer to example 2b. All right, so pause this, and then we'll move on to example 3. Do guided practice 2a and 2b. Okay, so let's look at example 3. So example 3 says multiplying radicals. So multiplying, and you could divide, but this is not dividing. So the key, it has a key concept box on the second page at the top that talks about summarizing. So what does it mean to be simplified? All right, so to simplify, so just like a monomial, we can multiply radicals, right? We already have the product rule. We said what has to have the same. We have to have the same index, and we can put it on our 1. Now to be simplified, the index n is as small as possible. We haven't gotten that. That's in the next lesson, so just put that in the back of your head. Don't worry about it for this section. The radicand contains no factors other than 1 that are nth powers of an integer or polynomial, meaning if your index is 4, you have less than 4 factors in there. You won't have 4 or more. The radicand contains no fractions, or you don't have a radical sign in the denominator. So that means the same thing because you can separate them and put them together. So let's look at multiplying this. So remember, this implies 5 times this radical times 3 times this radical. So remember, we have properties that say we can simplify this. So let's look at simplifying. So it's 5 cube root of negative 12ab to the 4th times 3 radical 18a squared b squared. Okay, so I'm going to rewrite this to say 5 times 3. I do have the same index, so guess what? I can put these all under the same thing. So negative 12 times 18 times a squared is a cubed. B to the 4th times b squared is b to the 6th. So you should know that 12 is 4 and 3. or 2, 2, 3. And 18 is 2 and 9, or 3, 3. So basically we have 5 times 3 is 15. The cube root of 2 times 2 times 2 times 3 times 3 times 3. And don't forget this little negative here. And then a cubed b to the 6. So because it's negative, and I take something out, I take out a negative 2. Well, I take a negative anyway. So we can take out a 2. We can take out a 3. Then we have 3 divided by 3 is 1, remainder 0. And then b, 6 divided by 3 is b2, remainder 0. So it's b squared, and there's nothing left. So now all I have to do is multiply this. So I get negative 6 times 30 is negative 90 ab squared is your answer. Okay, pause this and do guided practice 3a and 3b. So now we're headed to example 4. In example 4, we're going to use we've got a vocabulary, and we're going to use like real terms. So our vocabulary here is like radical expressions. So what does that mean? So what that means is when you have, let's look at it. So when both the index and the radicand are identical, this is key here to use this little like terms, unlike, and unlike. They give you examples. To be like terms, 2 things must happen. You must have the same index and the same radicand. If you don't, you cannot simplify it. All right, and we treat them like a monomial. So when they're like terms, and we add or subtract the coefficients, and this applies to both addition and subtraction. So let's look at example 4. So example 4 tells us let's add. Okay, so we said the rule for adding and subtracting, they don't give you a key concept, they just give you the unlike and like terms. So you've got to write this down. So the key the property says you must have the same index and the same radicand. So both my indexes are 2 implied 2, but I have different indexes. I mean different radicands. But let's see, can we simplify those? So you have the square root of 98 minus the square root of 32. Well, 98 breaks down to 2 times 2 times 7, 2 times 7 times 7, okay? 32 is 2 to the 5th power, all right? So here, I have a 2 and 2, 7, so I can take out a 7 and left with the square root of 2. Here, this is 2 to the 5th, so I can break that down to 2 to the 4th times 2 to the 1st. So 4 divided by 2 is 2, which is 2 squared. So I take out I already had a 2 out here. So I take out a 2 squared, which is 4 times 2 is 8, square root of 2. So if you're not sure how this is simplified, you can see me in class and we can go over that. So now my indexes are the same. Are my radicands the same? They are. So guess what I do? I simplify my radicals. So you have 7 minus 8 is negative 1. So my answer is negative square root of 2. That's simple. So pause it, do guided practice 4A and 4B, and we'll see example 5. Okay, so example 5, we have one more thing. So we have one more vocabulary, which is called the conjugate. We've already learned what conjugate is back in the past. So if I have a square root of b plus c square root of d, its conjugate is going to be the same thing. The only difference is this sign is going to be opposite. So if this was negative, the conjugate would change to a positive, right? What do we know? Just like we can add radicals, we can also multiply radicals, right? When they're more than one term. And we can use the FOIL method. Now, if I multiply these two, I'm multiplying the conjugate. We learn we multiply anything times its conjugate, the OI's cancel out. You are more than welcome to do the whole FOIL, but why when you know they equal 0? So all you have to do is the F and the L. So that's our vocabulary, and then I don't think there's any key concept box for the FOIL in this. No, there's not. So let's just go straight into example 5. So example 5 says simplify. So 4 square root of 3 plus 5 square root of 2, parentheses, 3 square root of 2 minus 6. Okay, so here the first thing we're going to do is we're going to FOIL. Look at them. Are they conjugates? No. So we have to do the entire FOIL. So first times first, so 4 square root of 3 times 3 square root of 2, outer times outer. So positive times a negative is a negative. 6 times 4 square root of 3. And then inner times inner, positive times a positive is a plus, so 5 square root of 2 times 3 square root of 2. This all implies multiplication. And then last times last is going to be positive times a negative is a negative. 6 times 5 square root of 2. So now we have to go and simplify. So 4 times 3 is 12. Square root of 3 times square root of 2 is square root of 6, and you can't simplify that. Here is square root of 24, square root of 3. And here it's 5 times 3 is 15. Square root of 2 times square root of 2 is square root of 4, which is times 2, right? Which this really is going to be the same thing as 30. There's no radical left. So plus 30. And then minus 6 times 5 is 30. Square root of 2 is prime. And this is your answer because you have no like terms, right? There's each radical sign is simplified as it can get, and all the indexes are the same. However, there's no radicand, so you can't add or subtract. That is simply your answer. Okay, so pause the video and do guided practice 5A and 5B, and we'll head to example 6. Okay, so example 6, this is where, the conjugate vocabulary comes in, is to rationalize the denominator. All right, so to rationalize a denominator, before when we had a monomial or one term, we would just look at the index and base it off that. Well, here we have two terms, so it's tied together. So let's look at example 6. So they tell us, refer to the beginning of the lesson and use, but we don't have to go back and look at, use the conjugate to rationalize the denominator and simplify. So we have square root of 5 minus 1. So again, you have to remember that this is tied together, okay? So, and it's two terms. You can't separate them. So in order to rationalize, we have to multiply by its conjugate, okay? We can't just say, oh, let's multiply by square root of 5, because we have two terms that's tied together, which means you have to distribute. It will get rid of this radical, but it'll add a radical back here. So we have to rationalize. Again, it's a fraction. Fraction rules. We still have to multiply by some form of 1. And the form of 1 here is its conjugate, which is square root of 5 plus 1. What we do to the denominator, we must do to the top. And we're multiplying, yes? Well, these are conjugates, so I only have to do the F and the L because the OI are going to cancel out. So first times first, square root of 5 times square root of 5 is square root of 25, which is 5. And then last times last is negative 1 times positive 1 is minus 1. And then here we have one term times two terms, so we have to just distribute. We don't have to FOIL. So 2 square root of 5 plus 4, and then so we have 2 square root of 5 plus 4 over 4. I'm sorry, this should say 4. Okay, now these don't cancel out. Remember, this is tied together. But what we can do, there's two ways of looking at it. Separate it using fraction rules. Okay, so this divide by 2 is 1, divide by 2 is 1. Remember, we have to do the same thing. So we end up with a square root of 5 over 2 plus 4 divided by 4 is 1, not 0. 1 over oh, I'm sorry, this was 1 here. So I'm making a mistake already. So this should be 2. So 2 over 4 is 1/2. By fraction rules, I can add these because I have the same denominator, so I have square root of 5 plus 1 over 2 is your answer. Or you could say this term and this term and this term have a GCF of 2, divide all by 2, and you get square root of 5 plus 1 over 2. So you get the same thing, it's just what makes sense to you. All right, pause it, do the guided practice 6, and we will see you at the next lesson.